Well, hello again. Today we're going to talk about how to solve quadratic equations by factoring. And this is probably review for a lot of you, so we're just going to cover some basic ideas and then just try and refresh on what some of this can actually mean. So when we have a quadratic equation, it means that at some point we had x squared. Now, I know that a lot of you have some different techniques, and right now in the educational field there's some different techniques. Some of you might be familiar with something like an algebra tiles, where you would have this square grid and you'd put your tiles in there and you'd make everything fit, and when you make the square you can just look along the edges and you know what you have, which is awesome. But sometimes, you know, we don't expect that and you don't have that available to you, so we want to make sure you can at least take care of this algebraically and just on paper. So the first step is to remember that when you've got something like this, the most important idea is that if it's equal to 0, and this only works if it's equal to 0, that if this term, this first term here, turns out to be a 0, it has no effect on this. Because if that turns out to be a 0, 0 times anything is 0. And that's that zero product property. And vice versa. So if this turned out to be a 0, it doesn't matter what that is. So the trick that you want to do is simply set each one of them to 0 with an OR between them. So after you get that set up, you now have two equations that you can solve for your answer. So x could be 2 by adding 2 to both sides. Or if you subtract 7 from this equation here, you get x is -7. So if you plug the 2 in here, 2 minus 2 is 0. And 0 times, this would turn out to be what, 9? 0 times 9 is still 0, so it doesn't matter. So it's good. And and vice versa, -7 plus 7 is 0. And 0 times a -9 this time would still be 0. So it works. They both work. So that's the basic idea of the zero product property. It's incredibly useful, incredibly important. Another idea that you have to deal with in terms of quadratics, when we have this guy, is making sure that we make every equation equal to 0. Well, when we had just something like maybe 3x equals 12, we don't have a quadratic because that's not squared, which means now we're trying to solve for that variable. And when we have a quadratic with the x squared, we can't do that. We have to get them all on the same side first and use some slightly different techniques. So part of the goal is to get it equal to 0. So we'll do that. 9x squared minus 24x plus 16 equals 0. Now here's something tricky. That number is not 1. And you guys might remember sometimes when you factored this, and you always saw this was kind of weird. When I first started tutoring, I didn't remember how to factor this either. And there's a few ways to go about it. The first thing to note is to just look and see, could this be represented as something squared? And it turns out it could be. This could be represented as 3x squared, and this guy here could be represented as 4 squared, which means that it might work out like this. We set up the parentheses, which you might be familiar with from an earlier section, and we'll simply put the 3x and the 4 at the beginning and end of each parenthesis. Well, they have to multiply to a positive, but they have to add to a negative, which means that I need a negative on both of them. So the multiplication will give me the positive 16, have a negative 12x, and another negative 12x for the negative 24. And lastly, the 3x times 3x is 9x squared. So yes, this works. So this is one of those unique cases you want to look for. If you have something where that is not equal to 1, that's how you can work about it. Strangely enough, they're actually the same, but it doesn't matter. We'll still use the same zero product property. 3x minus 4 equals 0. And 3x minus 4 also equals 0. We're being a little redundant here, but that's okay. Sit tight. Adding the 4, 3x equals 4. And then we can divide the 3, and get the 3. So x is 4/3. I'll make my x look a little nicer there. And if we were to do that over here, we'd get the same thing. Which means that if you were thinking about something, if you're one of those visual learners, if you remember what an x squared looks like, it looks kind of like a curve, right? In this case, it definitely opens upward. And because we get the same thing twice, it means that it actually touches on 4/3. So if I cut that into two little sections there, it means that it's actually coming down, touching it, and coming back up again, which is really kind of cool. So that's just a little bit of insight for what you might see in the future. Alrighty, one more to work on. So we have a quadratic again. It is equal to 0, so we're in good shape. But sometimes you want to look for things that they all have in common. Now in this problem over here, we had this 9 is 3 squared, so it only is made up of 3's. 24 could have been made up of 8 and 3, but 16 could only be made up of 2's and 4's. So they don't have all the same factor, but these do. So that's something you want to look for. Now you don't have to deal with that right away, but I'd recommend you do. How can we factor this out? Well, what do they share? Well, 72 is 9 times 8, and I know that 9 is 3 squared, so I know that I can take a 3 out of that. 6 is pretty clear, and so is 3. So I'm going to take out a -3 out of every term. So if I factor that out, it's kind of like division, but I got to write what I'm dividing by out here. So -6 divided by -3 is a positive 2x. And 72 and 3, I think that's 18, but I'm not sure, so I'm just going to go ahead and just do that really quick. 3 goes into 7 twice, 12. So what is that, 4? 24 times, okay. Now I have a positive divided by a negative, so that's a negative 24. Okay, so a little side work there. So I thought it was 18, it's actually 24. People make mistakes, it's okay. All right, now here's something that's kind of tricky. The book says only consider that which has an x in it for the zero product property, which is fine. You should, because if you put -3 equals 0, that's obviously not true. Here's the easy part. If you simply divide both sides by the coefficient, just the coefficient, which is a number, just a constant that you already know, it doesn't change anything. These cancel. -3 divided by -3 is just a 1. We get x squared plus 2x minus 24. And 0 divided by -3 is just 0. So that -3 there, completely useless. You can totally do without it. So, don't need these parentheses anymore. There's no need to group them. And now I've got a quadratic that's a lot easier to deal with. So I'll try factoring it first. What two numbers could multiply to 24, -24 in this case, but add to 2? Well, in order for me to do that, I like to use this kind of grouping method here. I put my -24 on the top of this large x here, and this 2 on the bottom. And I just run through the ideas of what it might be. Well, I know 6 times 4 is 24, but I have to make one of them negative, so I guess I'll make that guy negative. And hey, that works. So 6 times -4 is 24, and 6 plus a -4 is just 2. So that works. Great, I got it on the first shot. You know, what if I'd had thought of 8 and 3 first? Well, I have to make one of them negative for the multiplication. He has to be positive, so I'll make the smaller guy into a negative. But even 8 minus 3 is only 5, so that doesn't work, and I just cross it off. So I strongly recommend that you write down everything you think of and just check it. If it doesn't work, cross it off. It's better to write it down and get rid of it than to just try and dismiss it in your head. So we have a 6 and a -4, and the 6 was a positive, and then I'll just put my x's in the front. So x times x is x squared. I have a -4x and a positive 6x, so 6x and a -4x, well that is 2x, so that works. That's my middle term. And 6 times -4, I already found out, is -24. So now I can use zero product property. X plus 6 is 0, or x minus 4. Oh, ran out of room. X minus 4 is 0. Okay, same idea. Subtract the 6, subtract the 6. X is a -6, or x is a -4. And if you were to take these back in here, they would work.
Wouldn't that be 4?
Oh, there it is. There it is. There's the first mistake that required annotation. Yes, yes. See? And exactly the reason why I did that It wasn't intentional, but it's exactly why I did this, is I did not show my work. Add the 4 to both sides. Right, so I showed my work here, I got the proper sign. I forgot to show my work here, and I got the wrong sign. So yes, it is just a 4. Thank you. Which means that would not have worked, but now it does. 4 would work into this problem. So there's 3 different examples on how to solve these quadratics.